Frémy salt is a stable radical salt, mainly used in the oxidation of phenols to quinones. Depending on the conditions and the phenol used, it can selectively produce mildly unstable 1,2 quinones, more stable 1,4 quinones, or a mix of both, but no 1,3 quinones, because they would have this cursed allyne thing going on, so they usually just remove themselves from existence. Anyhow, Frémy salt is relatively simple to make, but it is notoriously difficult to store, since it can easily decompose if stored improperly, and potentially explode if it is sealed. So I will show a method to keep it stable for several months, and then try to make some unstable 1,2-benzoquinone. So to get started, I set up a stir plate and a large beaker. I drop in a stir bar, and then add in 100 ml of water. I add 34.5 grams of sodium nitrite and wait until it all dissolves. I then set it in an ice bath to cool it down. I also occasionally add ice into the beaker to make sure it stays cold. When it is ice cold, I add in 100 ml of a 37% sodium bisulfite solution and then 20 ml of glacial acetic acid. The mixture becomes clear again, but then gradually becomes dark yellow. In the reaction, sodium nitrite first reacts with acetic acid to form nitrous acid and sodium acetate. This then reacts with sodium bisulfite to form sodium hydroxylamine disulfonate. The reaction is finished within a few minutes, and I then destroy remaining acid and basify the solution by adding in 31 ml of 25% ammonia. Now I hang a separatory funnel above the beaker and add in 400 ml of a 0.2 molar potassium permanganate solution, and add it dropwise to the beaker. The permanganate will oxidize the hydroxylamine disulfonate salt to the radical nitrosodisulfonate, and at the same time form manganese dioxide, which precipitates as a brown solid. When all of the permanganate has been added, it has turned completely brown, and I take it out of the ice bath. I then set up a filter with a pre-wetted paper filter, and filter all of the mixture through. The filtered is a very dark purple, from the radical salt and not from the permanganate. When it has all filtered through, a brown cake of manganese dioxide is left, which I discarded. Now that I have all of the filtered, I can continue with the last step. So I set up a stir plate and a beaker and add in about 300 ml of water. I then add in a bunch of potassium chloride to make a saturated solution and wait until nothing more dissolves. Now I take a bit of the radical solution and pour it into a small beaker. I then add some saturated potassium chloride solution to precipitate out the Frémy salt. I add a stir bar and a little more of the potassium chloride solution. I leave it to stir, and after a while it spontaneously turns orange, which is the precipitated Frémy salt, which can be used to seed the main batch and precipitate out the Frémy salt easier and faster. I add in a bunch of the Frémy salt suspension to the large flask and then leave it to stir for a while. In the end, I divided it into 2 separate portions and then filtered all of it through a glass filter with a paper filter on top. When the filtration is finished, a bright yellow-orange solid is left behind. I then wash the solid once with a saturated potassium chloride solution that contains about 5 to 10% of 25% ammonia. Then I wash it twice with methanol that also contains 5 to 10% of 25% ammonia. And then finally once with some methanol. I dry it lightly on the filter and then transfer all of the solid to a crystallizing dish and let the methanol evaporate in the air. When it is dry, I am left with 47.85 grams of the bright orange-yellow Frémy salt. Now Frémy salt doesn't like being stored the normal way, since it will decompose in air, but also if any moisture is remaining in the salt. If it is not properly stored, it can decompose within several days and explode if it's sealed in a container. The only way to store it properly and keep it good for several months is in a desiccator with an ammonia-containing atmosphere. So to do that, I set up a desiccator and will use calcium oxide as a drying agent and ammonium carbonate to create an ammonia-containing atmosphere. I remove the top of the desiccator and the ceramic plate and fill the bottom generously with a bunch of calcium oxide. I put the plate back in and set the crystallizing dish with the Frémy salt inside. I then fill a small beaker with a bunch of ammonium carbonate and set that in a desiccator as well. The ammonium carbonate will release ammonia and keep some around in the desiccator, which will help keep the Frémy salt stable, and the calcium oxide will pull out all of the water. I then put the desiccator away until I'm ready to use it. So now I will show a reaction using the Frémy salt. Since it's able to oxidize phenols to quinones, we can make the unstable and red 1,2-benzoquinone, along with the commonly known and used 1,4-benzoquinone. So I set up a stir plate and an ice bath. I lower a flask into it and add in 250 ml of water and all of the Frémy salt that I made before. I melted and poured 7 grams of phenol into this beaker and then dissolved it in about 100 ml of diethyl ether and added that to the flask. I then left it to stir for a day and closed it with a stopper. In the reaction, the Frémy salt should oxidize the phenol to 1,4-benzoquinone and 1,2-benzoquinone. Normally it will always favor the formation of 1,4-benzoquinone when using phenol, but it seems that adding diethyl ether helps the formation of 1,2-benzoquinone instead. When I come back, the mixture has turned brown and the reaction should be finished. So I move it all to a separatory funnel and extract it 4 times with some diethyl ether. When that is done, I take the combined ether extracts and add in a large amount of sodium sulfate. Since a bunch of the wet solid came with the ether extracts, I dry out the brown solid by pulling out all of the water with sodium sulfate. I then filter all of it through some cotton directly into a flask. When the filtration is finished, I take the filtrate and set it up for short path vacuum distillation to remove all of the ether. Afterward, I pull out all of the remaining solvent in a strong vacuum, and at the same time try to vacuum sublime the product onto the cold finger. It was splashing a lot at the beginning, but afterward I melted off the solid from the sides with a heat gun and cleaned the cold finger. After a while, a bunch of red solid has collected on the cold finger, which corresponds with the color for the unstable 1,2-benzoquinone. I don't see any yellow from the 1,4-benzoquinone, but maybe that's for the better. Since the 1,2-benzoquinone is such a strong red, it is difficult to even know how much, if any, 1,4-benzoquinone has formed. A bunch of needle-like crystals also formed on the sides of the flask, some colorless, which might be unreacted phenol. To separate all the components is for sure a huge pain, so I'm not gonna bother trying any kind of purification. I scraped the red solid off the cold finger and placed it in a crystallizing dish, along with the black residue from the flask. Since 1,2-benzoquinone is so unstable and the material isn't pure, I just discarded all of it. Anyhow, that was an example of a possible reaction with Frémy salt. If all goes well, next week I will have a large video which I'm looking forward to. So see you then.